So what you see in front of you is Jupyter Notebook. And this is an IDE specifically for data science. So at first, this was a little hard for me to get my brain around because I have a background in software where the IDE, the purpose of it is to create executable software. It's not really the purpose of Jupyter Notebook as an IDE. And you can hear in the name the hint, notebook. So really what this IDE, the purpose of it is to answer a question. So you think of a data science challenge and you can create notes, create a little Python, create notes, create a little Python. At the end of the day, you can print it off and you have a copy of it. And it really serves as like a notebook. It's like the modern day equivalent of a graph paper notebook, which is something everyone loves. And it took me a while to get on board with that. But once I did, I really started understanding and liking Jupyter Notebook. So for starters, and I'll put links to how to download and install this, and possibly in the future, if people want it, I'll create a tutorial showing how to download and install it on Windows and Macs and Linux and everything. But it's pretty straightforward, and there's lots of tutorials you can find, and I'll put some links in the notes. Just in case you don't currently have Python and Jupyter Notebook, which are the two prerequisites for this tutorial. So we're doing an exploration of the strategy of doubling bets to see if that would work or not. And we want to use some data science tips and tricks to get it done. So I think this is going to involve a few different stages. This will probably turn into more than just one tutorial. But the first, let's start with, so you can see right now wiggling my cursor on the screen. And the cell that we're in, we're going to set the cell type to Markdown. That means that this isn't going to be Python code. This is just going to be some notes. So as I'm talking, I'll make some notes. So we'll make this a tutorial on strategy to make double bets on a game such as Roulette. This will be a multi-part tutorial, and today we're going to finish part one, which is to model the roulette wheel and maybe do just a titch of data science to see the output of the modeled roulette wheel. So part two will be to model a table. Let me just put that down. Part two, model a gambling table with min and max bets, which becomes important on the strategy of doubling bets. And part three will be to model the bet structure and, try to model 1,000 people doing thousands of bets and see what kind of graphs and data we can produce using data science. So again, this is a problem that isn't rocket science. It isn't too hard to solve. You could probably solve this with an Excel spreadsheet, but let's use it as an opportunity, since it's something we can get our brain around, to learn data science. Now, one thing you might notice is that this project is titled Untitled. So let's give it a title. You do that by just clicking at the top. And I'm going to call it, let's call it Martingale Strategy Simulator. All right, Martingale Strategy Sim. That's the name for it. Okay, now, time to do some real, not quite hardcore programming, but at least kind of dipping our toe into creating a little Python. So if you don't know Python, that's going to be important. That's something that is one of the sort of standard languages used in data science. And it's kind of... it's the sort of thing where you can spend a lot of time optimizing your Python code to be elegant and performant. But since we're just trying to answer questions, let's kind of just brute force through our Python code. And if someone has suggestions, or if I do something in a suboptimal way, feel free to make a comment. But for the purpose of this tutorial, this is not like learning Python. This is really like getting Python to do what we need it to do for answering a question. When you think of it that way, it's not, it doesn't have to be the most optimized or elegant Python in the world. So that said, we are going to go to the trouble of creating a class. And I think that's probably important for this problem. We're going to create a class called Roulette Wheel. And this class is, if you don't know what a class is, if you're kind of new to Python programming or programming in general, a class is like a blueprint for something that can be created again and again and again and again. They call that instantiated or constructed. You can keep creating. You can create a blueprint for a roulette wheel, and then you can create 50 roulette wheels, and then you can run those roulette wheels hundreds of times each. So you can see how that would be really good for data science, where we're trying to sort of assess the probabilities of outcomes. Step one is to create that blueprint of a roulette wheel. So when we're creating a class, we start with the Python keyword, and let's just make sure that this cell is set to Python code. All right. So we start with the keyword class, and you can tell it's been set to Python because that suddenly turned green. So I'm going to call the class roulette wheel. All right. Now, kind of a good practice is to include a little blurb about what your class is. So I'm going to do that here. When you have 3 quotes right after the start of a class, that becomes the documentation for that class inside the code. So if you're using that class somewhere else in certain IDEs, you'll mouse over it and it'll tell you, hey, this is the roulette wheel class. It does blah, 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 blah. So I'm just going to create that documentation really quick. The roulette wheel class creates a model of a fair roulette wheel. It's kind of obvious, I suppose. So there's something called instantiation of a class or construction of a class instance. So a class is a blueprint, but when you're using the class, you create an instance. So in Python, they have like an init method inside the class that defines what happens in every instance. In this case, I tend to call that a constructor from having learned Java in the past. So I'm going to just say, I'm going to explain that this class has a default constructor in this little overview of the class. This will make a little more sense in a second once I start typing it. But the default constructor is a wheel with a 0 and a 0, 0. All right. So there's your documentation for the Python class. Okay, and now there are 2 things when you think of classes. And by the way, it's really worth your time. One of the things that I actually kind of love about Python is when I Google how to solve certain things in like Java, inevitably I'll end up in a place like Stack Overflow, where I'll see some previous person trying to solve the problem. When I Google how to solve things in the language of Python, more often than not, I actually end up in the Python docs themselves. And that's what this is right here, the Python documentation page. You can see that it's pretty easily written. It's pretty clear to understand. It's definitely worth your time just to read this, to learn about classes. Here's the class keyword. Here is a attribute reference that comes with every template of a class, and then they say this is an instantiator or a constructor for a class. The instantiation operation, calling a class object, creates an empty object. However, we might want to have some initial values. You're going to see that in a roulette wheel for sure. And then how to call a class, you just say variable name equals my class, and then boom, you've got a template that it calls from to create an instance of that class. So I highly recommend digging into the Python docs. They're a joy to read. They're really not that hard. They're easy to understand. It's like a good manual for Python. Nonetheless, so let's kind of get through this concept of certain information will be in any roulette wheel. And some information will be specific to the roulette wheel. If you're walking around Vegas looking at roulette wheels, usually you'll see one with a 0 and a double 0. Sometimes you'll see one with a 0, a double 0, and a triple 0. And sometimes you'll see one with just 1 0. And the 1 0 ones have a better payoff than the double 0 or dreaded triple 0 ones. So those would be 3 different types of instances of the class roulette wheel. So one thing that I think wouldn't change from roulette wheel to roulette wheel would be the win payout. And we're talking about for red black here. And that would be double. So if you bet $10 on red and it comes up red, you get $20 back. So 2 times is the payout. So this is the payout for red, black. And I'm not going to deal with even and odds. Let's just say red and black winning. Lose payout equals 0. You bet on black, it comes up red, you bet $10, you get 0 back, right? So the lose payout is 0. So those are true whether you got 1 0, 2 zeros, 3 zeros, in terms of your roulette wheel. Like if you have a green 1 0 or green double 0, those are true. You win 2 times, you lose 0. So that's the payouts. Those will be the same across all instances. But now let's define an instance using this keyword and the standard self, and we'll call this the default constructor with double 0 and single 0, right? Because that's the most typical one these days, sadly. And we're going to define something called wheel. And it is going to have, and I might zip through this. There's a lot of ways of writing this. I could write this more curtly by having a range statement. But I think by saying 1, 2, 3, all the way up to 36, and then the aughts, the 0, and then the 2 zeros, I think by making that explicit, it's a little bit more readable and a little bit more understandable. So, bear with me, or maybe we'll do a little cake baking and cut through this. I think this is, even though it's a little bit ridiculous, it's more understandable than just saying range, 1 to 37, comma 1. There's lots of different ways to say this, but I want to do it the most understandable, brute force, obvious way that I possibly can, and that is to just list them all out. And then single quote, O, call it a capital O, and then single quote, let's make it a 0, make it an actual 0, 0, and then single quote 0, 0, 0. All right. So now this is a list, and you can see how this could be like a wheel, and you spin the wheel and you land on a 12. Spin the wheel again, you land on a 0. Spin the wheel again, you land on a 35. So that's starting to be your model of a double 0 version of a roulette wheel. Let's say, this will become important later, but let's just say integer position equals 0. So if it's a brand new wheel, it's sitting on the 1. It's sitting on, lists in Python start at 0. So if you think about this list that goes from 1 to 36 to 0 to 0, 0, it starts at 0 is the 1, and 1 is the 2, and 3, 2 is the 3, and so on, all the way to 37 would be the 0 zeros. So we're saying our integer position starting at 0 is 0. So like out of the factory, that little ball sits at the 0. And that's just something we're saying just so it'll have a starting point so nothing will break before someone spins the wheel. It's just kind of like a safe starting point for the wheel. Rather than having it be a null, we'll set it to 0, the 0th position. Starting point for a fresh wheel. Make sense? Hope that makes sense. All right, now that's your constructor. That's what creates an instance of a double zero wheel. Going on, we'll want to create a single zero wheel and a triple zero wheel just to kind of test those cases. But for this particular tutorial, we're going to start just with a double zero one, just for simplicity's sake for now. It'll be easy to refactor later to add more instance types. So now we need to make a method for this wheel, and that is going to be spin wheel. Makes sense, right? That's something a wheel does. So methods are things that an object does. Attributes are things that an object has. So in this case, we're going to spin the wheel. So how do you do that? You spin the wheel, and where the ball lands, if it's a fair wheel, is a random thing. So we want to use a random function. So for that, I'm going to have to import the function random. And that is something that'll be useful for pulling out random numbers. So we'll type import random at the top, and that'll give us the ability to use random numbers. So what happens? You type self.int position, and it's going to equal random.randint 0,37. So remember how I said that the first position on the wheel is 0, and if it's a double zero wheel, the last position is 37. So this is going to give you a random number between 0 and 37, and then when you overlay it on that wheel that we've defined, out will pop a number like 23, or out will pop 32, based on, you know, a random selection off all those possible numbers, equally random selection. So now we're going to return, at the end of every method, we return self.int position. Super nice thing about IDEs is you can hit tab and it completes your line for you. So that's really nice. If you're new to the world of IDEs, then I'm going to have to create some tutorials on using this IDE because it gives you all kinds of magic stuff. Now let's create a couple of get methods that will give us our results in terms of numbers or in terms of colors. So we're going to say get spin result. All right, self. And this is pretty straightforward. We'll just return. We have to turn this into a string because we're going to want to use this as a string later on. So that str converts what I'm saying to a string. Self.wheel is been defined in the initializer, self.wheel, and self.int position. So that if this is a brand new fresh wheel that's never been spun, you're going to always end up with it sitting on the 1. If it's a wheel that's been spun, you're going to end up with some random number. Could be 17, could be 32, could be 1 if it randomly picks the 0 out of that. So get spin result, we'll return one of these as a string. All right. Now then, let's do get color. We're not going to deal with the wheel specific positions so much. We're mostly going to deal with red, black. So we will use this function a lot, the get color function that we're creating for the roulette wheel class. So, you know, as humans, we just look at the wheel and we see what color it is, and then the person behind the wheel puts the marker down on the color. In this case, we have to tell the computer to calculate it or figure it out. So first, we're going to create a variable that's empty that's called color, And then if self.int position equals 37. Again, these methods are being written heavily assuming 20 wheels. So as we go back in the future and change that to a single zero or a triple zero, we're going to have to rewrite and refactor a fair amount of stuff here. But I think that's okay. If it ends up being on position 37, that's 00, and your color is is green. If let's go ahead and just drop out right once we see that. Return, if that's true, return color. Now, if self.int position equals 36, color also equals green. That's single zero. So go ahead and return color. Now, if self.int position, so there's something called modulo. That's a nice thing that programmers learn. Basically is saying what's the remainder when it's divided by 2. So if you take 3 and you divide it by 2, you get a remainder of 1. Remember remainders from like grade school? That's what modulo does. And so we're saying if the modulo of the integer of the position gives a remainder of 1 when it's divided by 2, then you definitely have an odd number. So this is when you have an odd number, and that means that your color would be black. And the last case, if int position modulo 2, you could say is equal to 0. That's probably the right thing to do. And this is where you have an even number. If you divide something by 2 and you get a remainder of 0, you've got an even number, right? Then the color in this case is red, if I'm not mistaken. I think that's how a table works. The wheels of these. And return the color. There you go. That is a back of the napkin class for a roulette wheel. That you can use to create lots of instances. I mean, that said, let's make sure it works, right? So we'll fire it up and instantiate it and make sure this puppy really works. So let's say this is a fair roulette wheel. Ridiculously long name, but who cares? Roulette wheel. So remember from the Python docs, that's how you invoke a class, right? So come up with a variable, set it equal to the class. Let's run it and just see if it doesn't crash. So it didn't have any output, but it didn't crash. So I think that worked so far. So let's do some things with the roulette wheel. Let's go ahead and make a bunch of spins with the roulette wheel. And we'll have the results go into a list. So this is called a for loop in Python. For loops are really, really helpful. And basically, I'm just going to have it run through something about 50 times to create a list. Let's say this is a fair roulette wheel dot. Remember how up above, when we created this template of a roulette wheel, we defined something called spin wheel? So you call it by just typing dot spin wheel. So this is a really fair roulette wheel, spin that wheel. Kind of makes sense, right? Now we're going to take a bunch of spins, which is the results of that, and append this is a fair roulette wheel dot that other method we did, get color, right? So that's going to return a color, and it's going to do that 50 times. So 50 times it's going to spin the roulette wheel and get the color and write that color into something we call bunch of spins. So when we're done, if we say print bunch of spins, it should print a list of black, red, 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 black, red, green, green, right? So let's see if that worked. Look at that. Green, black, red, 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 black, red, red. So it worked. So pretty quickly, we've got a nice little blueprint of a roulette wheel, and we have a constructor for a particular type of roulette wheel, which we might want to create a new kind of constructor later, and then maybe add some variables to figure out which type of roulette wheel you've got. And we ran a little model of it saying, go ahead and spin that puppy a few times and see what happens. And so this has worked for us. We've got a nice little model. And, you know, now that we've got that model, I think it's time to do just a titch of data science, because we're all here to learn data science, right? So let's take that model and add... Is that how you spell titch? I don't know. My daughter says it a lot, I think because she watches Peppa Pig. Let's add some data science-y stuff into this model. And let's make sure that it's not using Python in a markdown cell. All right. I want to show a histogram. So a histogram is a graph where you group the number of times something happens, and you get this like nice distribution picture of showing how many times. So you know what I want to do is I want to create a histogram that shows how many times black has gone in a row. So you got one time, that's a one time, another one time, another one time, another one time, wow. 1, 2, 3, 4. So there, it was 4 in a row there. Then a one time, then a 1, 2, 3. So right there, you've got a bunch of ones, nothing at 2, you got a 3, and you got a 4. So if we do this like, I don't know, 10,000 times, 100,000 times, how many times will black come out in a row? I don't know. Let's find out, and let's make a histogram to do that. So we're not anywhere near being able to answer the questions of does the martingale strategy work, but even at this point, we can have some fun with the data, and we can make it output a fun little graph. So I'm going to insert a cell below, make sure this puppy is Python, and let's do it. All right, so we're going to create another roulette wheel, and we're going to use the class roulette wheel that we created. That creates another roulette wheel, and we're going to do lots, like really lots of spins, like, I don't know, thousands and thousands. You know, maybe let's do like 100,000. The processor will just eat it up. It's not a problem. So for I in range, yeah, I'm gonna do like, let's do like 500,000 spins for real. Is that 500,000? Yeah, let's really go for it. Another roulette wheel, spin wheel, really lots of spins, append, another roulette wheel, get color. All right, so there, now we're creating a super long list of red, black, red, black, 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 red, red, black, 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 kind of a super long list that's like 500,000 long. It's just like spinning that thing 500,000 times. So what I need to do now is I need to write a little function that will count the number of consecutive spins. So let's call it def. I'm just going to call it generically, but let's just focus on the number of blacks in a row, right? So we're going to look at the number of times it lands on black in a row. But I'll just call it count consec spins. That's pretty clear. And include spins list. So we'll figure that we'll always figure that we've created a list of spins like we just have. So before we do that, let's just test it and make sure that this works. I want to do a little quick test on this. So really lots of spins, and let's run this puppy. This is going to be like 500,000 long. Boom! Look at that. That is, and at the end it says ... Like, it just gave up. Instead of going all the way to 500,000, it just said, yeah, and even more. But, you know, we can programmatically reach into the memory and pull out this long, long, long list. So I just wanted to make sure that really lots of spins worked. It clearly did. So now I'm going to comment that out because we don't need to have that there. But yeah, looks like we've got a list of 500,000 spins. So now we're going to count the number of consecutive, I'll just spell the whole thing out, consecutive spins. I like spelling things out, makes it easier to understand. So some number in a row is going to be an array or list. I say array or list interchangeably. Again, long time ago I studied Java, and in Java they say array, and Python they say list. So I use them interchangeably. Let's make a temporary counter and set that equal to 0. For I in, so we're going to pass in, the thing that we're passing in is always going to be an array or a list of spins. So we're calling it spins list. And Python does this neat thing. It knows a list is so many long. So in other languages, you might have to say length of list, for I in length of list, you know, increment. In this language with a for loop, you just say for I in spin list, and it just goes result, 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 just steps right through them. So if I is not equal to black, number in a row, append, temp count. So if you have a bunch of reds at the beginning or a bunch of greens, you'll get like a 0, 0, 0, 0, 0, I think. Yeah, 0 doesn't really matter so much. It's just kind of a bootstrapping up this function. There's definitely a better way to write this function, but let's just do it this way for now. Temp count 0. The boundary conditions are a little tricky in this. Else temp count. Once again, I know there's like easier ways of doing things or more elegant ways of doing things, but I really just like making things as brute force and explicit as possible. So add 1 to temp count. Turn temp count into thing plus 1 if the number isn't black. If the number is black. So if it's anything but black, you say done. How many do we get? If it is black, you add another increment to it. And then if it's black again, then you pass that and you add another 1 to it. If it's black again, you pass that, you add another. Now you got 3 in a row. Then it comes back red and it says, all right, write 3 into the array and set it back to 0 again, looking for the next black to count how many blacks you'll have one after the other. So with any function, so this isn't a class, this is a function. And with any function, you need to return a result at the end. And we're going to return the result number in a row, which is an array of, you know, how many times black happens in a row. Okay, so let's try this. Black results equals count consecutive spins, and we're going to throw in really lots of spins. And let's see if this works. All right, logical error. What did I do wrong here? Local variable temp count is referenced before assignment. Interesting. I don't understand why I put temp counter equals 0, but when I was typing it, I put temp count. So I'm going to keep it temp count. That should solve things. All right, no error is good news, so that means things worked. Now, I want to plot this as a histogram. So And we're going to do some more of that importing that you saw earlier. Remember in the previous function where we imported random so that the roulette wheel class would know how to pick a random number? Now I'm going to import some data science magic that will be able to plot a histogram pretty much for free, pretty much with just a couple lines of code. So we're going to import a library called numpy, and then we're going to import matplotlib, and that's matplotlib, not mathplotlib, pyplot as plot. So then we only have to type plt. See how much time I've saved? So then we take this result and we go plot histogram black results, the number of continuous black results. So look at that. So you can see there is up to 16 times in a row, it looks like, while the data drops off pretty fast. Primarily it happens 1 time, 2 times, 4 times, 6 times, sometimes 8 and 9 times, you can see, and then very, very, very small line beyond 9 times. So that's just a nice histogram. So I hope you enjoyed part 1 of a tutorial on how to beat Vegas at their own game. Just kidding. Don't actually go to Vegas and lose all your money because of anything I say, please. And part 2 is going to include modeling mins and max bets on a table, which is important with the strategy of doubling. So this is the first time I've ever said this, and I'm an engineer and a bit of an introvert. I've also been a manager, but at the end of the day, I'm one of those INTJ types, so I feel a little bit uncomfortable saying, please like and subscribe. But, you know, please like and subscribe. Doesn't cost you a thing, and it means a lot to me. And if you have any questions or comments, or you have any ideas for other tutorials, or if you hate the way I code Python and you want to flame me, please, by all means, leave a comment below, and I appreciate you. And if you like data and learning and growing, I appreciate you, and thanks very much.